Hi, Assalamualaikum, and welcome back to the second part of your flipped classroom lecture. And this part of the lecture, we're going to be covering geometric sequences and whatever comes after it before we enter binomial series and so on and so forth. Okay, so previously it was arithmetic sequence and series, where arithmetic stands for hasil tambah A plus N minus 1 multiplied by the common difference D. Hasil tambah atau tolak lah. It's common difference. So, geometric meaning it is hasil darab ataupun bahagi. Okay, so geometric progression. What is geometric progression? We've learned this in SPM. So geometric progression is a sequence of numbers in which any term can be obtained from the previous term by multiplying by a certain fixed number called a common ratio. So previously it was a common difference. Now for geometric progression, it is a common ratio. A geometric progression is also known as a geometric sequence or inaccurately as geometric series. Okay, so moving on. A geometric sequence can be written as A times R, AR times another R, AR squared times another R, AR cube times another R up until Rn minus 1. Okay, so this is A is still known as the first term, whereas R is known as the common difference. So AR power n minus 1. So since if the first term is n is equals to 1, n minus 1 would equal to 0. So AR power 0 and R power 0 is equals to 1 would just equal to A. So that's why the first term is just A. The second term is A multiplied by R. The third term would be A multiplied by R squared, sorry. And the fourth term would be AR cube, and so on and so forth until the nth term, AR power n minus 1. Okay, so the general term of a geometric sequence is given as Tn is equals to AR power n minus 1. It will always be like this. Okay, so geometric sequence is AR n minus 1. Arithmetic sequence is A plus n minus 1 multiplied by D. So know the difference between arithmetic and geometric. Okay, so the common ratio R can be looked for by dividing the second term over the first term or the third term over the second term, also known as the Tn over Tn minus 1. So R is equals to Tn over Tn minus 1. So as long as you are given two sequential terms, okay, you can definitely look for the common ratio. Now let's look at a few examples. Find the general term for the geometric sequence 8, 16, 32, and 64. So write down all the information that you have, okay? So we're writing down all the information that you have is that the first term is equals to 8, the second term is equals to 16, the third term is equals to 32, the fourth term is equals to 64. So you can definitely look for the common ratio, and the common ratio is always Tn over Tn minus 1. Tn, and now is n is equals to 3 over Tn minus 1. So 3 minus 1 is 2, and so on and so forth. So common ratio is equals to 16 over 16 over 8, which is 2, 32 over 16, which is also 2, and 64 over 32, which is also 2. And your A is equals to 8. So put them in this geometric sequence, 8, given your A. R is equals to 2 and minus 1. So your geometric sequence is equals to 2 cube 2 power n minus 1. So since they have a common, I forgot what is this called, common index, okay? So you can actually add the 3 and the n minus 1. So n minus 1 plus 3 is equals to n plus 2, okay? So moving on. Moving on to the second example, find the ninth term of the geometric sequence 27, 9, and 3. Okay, so what's the first thing that you have to look for when you need a geometric sequence is that you have to look for A, which is the first term, which is already given here as 27, and R, which is the common ratio. And R is equals to the second term divided by the first term, or the third term divided by the second term. So let's write down all the information that we have. That is always what you always have to do. Start by writing down your information. So T1 is equals to 27, T2 is equals to 9, T3 is equals to 3. So A is equals to 27 and R is equals to 9 over 27. And we can definitely simplify that further. To become 1 over 3. So Tn would equals to AR power n minus 1. A now is 27. R is 1 over 3. And then the n that we are looking for is 9. So n minus 1 would be 8. Fill the A and the R up, and you can definitely get your ninth term. Okay, so simplify that as far as much possible, and you get that it is equals to 1 over 243. Moving on, so we've discussed the sequence. So then there's definitely the series, and series, of course, is also known as the sum. Okay, so a geometric sequence is AR squared, AR cubed, so on and so forth, up until ARn minus 1. Okay, so the sum of the first n terms of a geometric sequence is Sn. It's still the same, Sn, and it follows that it is A plus AR squared plus AR cubed, and so on and so forth, up until ARn minus 1. Okay, so just like your arithmetic series, this can be simplified. Okay, this can be simplified here. So let's try to simplify that. Okay, we're going to be multiplying it by R, and it is given that R Sn would equal to AR plus AR squared plus AR cubed plus AR4, so on and so forth, up until ARn. Okay, sebab sudah tambah satu R, so dia jadi from n minus 1, dia jadi AR power n. Okay, moving on. So we're going to subtract Sn tolak R Sn, the ones that we found before, these two here. We're going to subtract these two equations. Okay, so let's do that. Okay, subtracting these two will leave us with Sn minus Sn minus 1. Okay, kalau buka kurungan ni, you're going to find that they will all be cancelling it out, cancel out each other. AR minus AR, AR squared minus AR squared, so on and so forth, only leaving you with A minus AR power n. And this here is actually equals to Sn minus Sn minus 1. Okay, so that gives you your formula of sum of the nth partial sum of a geometric sequence equals to Sn is equals to A 1 minus R power n divided by 1 minus R. And if R is more than 1, A R power n minus 1 over R minus 1. Okay, so the difference is when it is less than 1, the 1 comes first, then the R. When it is more than 1, the R comes first, then the 1. Okay, this is to avoid negative sums. Okay, we don't want negative sums. Now let's look at a few examples. So we've got the fifth partial sum. We're going to have to look for the fifth partial sum of a geometric series in which the common difference, the common ratio, is given, and also the first term. Okay, so putting all the information that you have into your solution. Okay, always start by doing that. Okay, we find that R here is equals to, less than 1. So which formula do we use? We use the one that is the 1 in front. Okay, 1 minus R instead of R minus 1. So we know A, we know R. We are looking for N equals to, apa tadi? 9. Oh, 5. Okay, so we're looking for n is equals to 5. So just put in what is your a, what is your r, and what is your n, and you should get your answer. Very straightforward. Okay, now let's look at another example. So given that the first term of a geometric series is 27, so this is your a, and that the common ratio is 4 over 3. So your common ratio R is 4 over 3, and 4 over 3 is is more than 1. Very tricky here. It says 4 over 3. For an instant, when you look at it, you see that it is a fraction. So you automatically assume that it is less than 1. But looking at it carefully again, 4 is actually bigger than 3. So that means it is more than 1. So the question now says that you have to look for find the least number of terms the sequence can have if its sum exceeds 550. So we're looking for Sn. What is n if Sn equals to 550? That is what the question is saying. Write down all the informations that you have. You have that a is equals to 27, r is equals to 4 over 3, and your Sn is equals to 550, but you don't know what n is. Okay, and r here is more than 1. So we're going to use the formula with the r first, then minus 1. Okay, so this whole formula here is equals to 550 or about 550. We're not sure yet because n has to be a natural number. It cannot be in terms of perpuluhan. Cannot be in terms of perpuluhan. So we know what A, we know what R is. Let's put those in. Okay, and then using algebra, you can definitely solve that. So 4 over 3 power n is equals to 631 over 81. Okay, we're going to have to log both sides to take the n out. Okay, we're logging both sides, so n goes out. So tekan calculator, log 4 over 3 dapat apa? Okay, and log 631 over 81 dapat apa? You can definitely get your n. Okay, so the question says the least number. So 7.136 gives you 550. So therefore, n should be equals to 8. It should be more because if n is equals to 7, then it will be less than 550. Okay, so n is equals to 8. So pick the one that is more. Now, just like arithmetic, you have geometric mean. Okay, so if a number b is inserted between a pair of numbers a and c such that a, b, c are in geometric sequence, then b is said to be geometric mean of a and c. Okay, just like your arithmetic tadi, but tadi arithmetic mean we used a and b, and that your arithmetic mean is m. Now it's geometric sequence. We're going to use a and c, and that your geometric mean is b. Okay, so it follows that b over a is equals to c over b. Of course, this is the common ratio. Or b squared is equals to c multiplied by a. We just changed this a little. The b is multiplied over to the left-hand side and the a is multiplied over to the right-hand side. And you get that b squared is equals to c times a. So b now equals to the square root of CA, and the square root of CA also is also the plus and the minus. Okay, so for any three consecutive terms of a geometric sequence, the middle term is the geometric mean of the other two, and it is equal to the square root of their product. Okay, so CA is called a product, so the square root of CA is the square root of the product. So let's look at this example. Find the geometric mean of the following pairs of number. So your A is 4, your C is 16. We're going to have to look for B. Okay. So geometric mean is equals to the square root of the product of 4 and 16. So 4 times 16 is 64. And square root of 64 is plus minus 8. The other question was 8 and 18. 8 times 18 is 144. Yeah, and the square root of 144 is plus minus 12. That's all. Okay, so means, geometric means and arithmetic means may seem simple, but take note, okay, because these simple things are usually the favorite. Okay, now just like your arithmetic mean, what if now your sum is to infinity instead of a certain finite number of 5 or 7 or 10? Now it's infinity. So sum to infinity of a geometric sequence is given by s to infinity is equals to the sum of a r n minus 1 of n is equals to 1 up until infinity. So of course this is impossible to calculate, but we can estimate it by it with a over 1 minus r, given that the modulus of r, that means positive or negative, we make it into positive, is less than 1. Okay? Okay. I'm going to skip this proof. Okay? You can read these proof out on your own. It's not that important. We're never going to ask you to prove it. Okay? This is just so you know that we're not just tembaking the s to infinity. It is based on proof. Okay? And it requires limit and continuity chapter. All right, that's a later on chapter. So notice that the proof of this result is valid for r less than 1 and more than negative 1 only. So if this is not the case, that means your r is more than 1. Okay, then the sum to infinity does not exist. So the sum of infinity of a geometric sequence, if your common ratio is less than 1 or more than negative 1, is always and always and always given by a over 1 minus r. Okay, so if it is more than 1, it does not exist. Remember that. The sum to infinity of a geometric progression is 7, and the sum of the first two terms is 48 over 7. So you've got s infinity equals to 7, s2 is 48 over 7. Okay, so now we're going to have to show that the common ratio r satisfies the equation 1 minus 49 r squared, and it is equals to 0. Hence, find the first term of the geometric progression with positive common ratio. Okay, now let's see. Always start by writing down your information. They said that sum to infinity is equals to 7. So sum to infinity is equals to 1 over 1 minus r, and that is equals to 7. Move around a little using algebra, and that gives you your first equation. Okay, and that the second partial sum is equals to 48 over 7, and that's a plus ar, and that there is equals to 48 over 7. So this will be your second equation. Two unknowns, a and r, and two equations. So naturally, simultaneous equation. Okay, now I'm going to explain the simultaneous equation. I'm going to skip this. You're going to have to look at that your own. Okay, but once you've rearranged that, you will get 1 minus 49 r squared is equals to 0. So this proves your question. So we're still going to have to solve for r. Okay, so r is equals to 1 over 7 and negative 1 over 7, but the question did say that it has to be positive. Okay, so we're just going to take r is equals to 1 over 7. All right, so a is equals to 7, 1 minus r from the first equation. Okay, we can definitely look for your first term, and the first term is equals to 6. So the first term of the geometric progression with positive common ratio is 6. So you've answered the question. You've shown that it is equals to 1 minus 49 r squared is equals to 0, and that with a common ratio that is positive, the first term is equals to 6.